Hello students, my name is Chiranjit Ghosh from Electrical Engineering Department of Shantinidhi Institute of Polytechnic. Yesterday we will discuss about the block diagram in a control system. Today we will discuss about the signal flow graph or SFG. These are very simple and this is also a technique for block diagram, like that block diagram reduction technique, and it will be used to find out the transfer function of any signal or any systems. Okay, so here we will see that this is a block where x1 is the input, a is a gain and x2 is the output. From the block diagram we know that when x1 is the input, x2 is the output, therefore we can say x2 by x1, that means output by input equals to gain, or also we can say output equals to gain into input, that means x2 equal to a into x1. Okay, when it will convert it from the block diagram to signal flow graph, we can see that here this x1 input is symbol is a dotted and x2 is also a dot, and a which will be a simplifies by a arrow a. Okay, where this x1 is a input node, x2 is a output node, and a is a transmittance or gain. Okay, so we can say that output node equals to input node into transmittance from the above equation, x2 equal to a into x1. So we can say that x2 equals to a into x1. Okay, number 2 example. Okay, we will see that this is a block diagram and this is a signal flow. At first we will solve a block, after that we will solve a signal flow and check whether this answer is a right or wrong, both. Okay, so at first x1 is a input. Okay, x1 input, after that again a there, then we will go a summing point, then again is a b, and after that we will get output x3, and c is a feedback which will be a negative feedback. So we can say that x3 by x1 equals to, we know that for closed loop control system it will be solved by gain by 1 plus minus gain into feedback. So we can write b by 1 plus bc, where y plus because of the negative feedback. We know that for negative feedback it will be a positive. So we can say b by 1 plus bc into this gain a. Okay, so also we know that x3 equal to x1 into b into a by a plus bc, or x3 by x1 equal to ab by 1 plus bc. Okay, when it will convert it into a signal flow graph, we can say that x1 is a input, so x1 is a dot, therefore it will be a is a gain like that arrow, and after that the summing point also a dot x2, and x3 is a output, it will be get a dot. Okay, and b is a gain, so b is also a this symbol is a b, and c is a feedback in opposite direction, and which will be a minus, therefore it will be a minus c. Okay, so we can write that there it will be solved by this node position. Okay, so it will be solved by the help of these arrows, or these are incoming and outgoings, gain or feedback are incoming and outgoing in a node. Okay, we will take it. Okay, for x2 here, x1 and a into x1 is coming, therefore x2 equal to a into x1, and b into x3 are leave from x2, therefore minus c, and incoming is a minus c is a feedback. So we will take those factors are come in a node, we will take it. Okay, so here x1 there is no any incoming any signal or incoming any gain, so the x1 is cannot be significant, so x1 equals to 0. Here x2, a and x1 is a coming, therefore we can say ax1, and c into x3 and c is also a coming in a node x2, therefore we can say plus of minus c into x3, and plus minus minus, so we can say ax1 minus c into x3, and x3 here at this node coming is a gain b, so we can write x3 equal to b into x2. Okay, when I solve it, x3 equal to b into x2. We know x2 equal to ax1 minus cx3. So put b equal to x1 minus cx3 and x3 equal to abx1 minus bcx3. So x3 is a gone in our left hand side, so x3 will be a common, so we can write 1 minus bc equal to ab into x1, or x3 by x1 equal to ab by 1 plus bc. So here we can see from the block diagram x3 by x1 equal to ab by 1 plus bc, and also we can see that from the solving of a signal flow graph, here x3 by x1 equal to ab by 1 plus bc. So we can say that the block diagram and signal flow are used to help to reduce the transfer function and find out this value. Okay, so now we can state the Mason's gain formula. It will be a help to find out the signal flow graph. Okay, so what is the Mason's gain formula? Here Mason's gain formula is a T equals to summation of k equal to 1 to infinity pk del k by del, where t equal to transfer function, pk equal to forward path transmittance. It will be up to k terms, del k equal to path factor corresponding path up to k, and this del it be find out by the 1 minus summation of all individual loops. Individual loops mean those loops which will be created. These are individual loop. Those loop will be created. The loops means when a point will start to flow and come out at this node. Okay, so we will see from x2 it will be go to the x3 and then by the help of feedback minus 3 and come into a x2. So this is a loop. Okay, so these are the individual loops. Okay, so we can say that 1 minus summation of all individual loops plus summation of pair of non-touching loops, minus summation of triple of non-touching loops. Okay, those loops are non-touching to another. These are non-touching loop. Okay, so we can say that summation of pair of non-touching loop minus summation of triple of non-touching loop plus dot dot dot. Okay, now I will tell you what is a path factor. Path factor is a all loops are touching anywhere corresponding the path. We know that what is a forward path. Forward path means these are the x1 to x3. This path is called forward path. x1 to x2 and x2 to x3. These are starting point and these are finishing point. However, when we go from starting point to finishing point with a various kind of way, these are called a forward path. Okay, so where all loops are touching anywhere corresponding the path factor is 1. Otherwise, those loops are not touching anywhere corresponding this path. These loops are negative from path factor 1. Okay, so this is the concept of a path factor. And touching loops means if loop are connecting each other through a common node, then they are called a touching loops. Touching loop means two loops are connected with a single node. Okay, therefore it is called a touching loop. We will see one solution or one example like that. x1, x2, x3, x4 and x5, there are 5 nodes. Okay, and x1 to x2 the gain is a x2 to x3 gain is a b, x3 to x4 gain is a c, x4 to x5 gain is a d. So x1 is a starting point, x5 is a finishing point. This is called a path. Okay, and we know that when we will go from starting point to finishing point with a path is called a forward path. Okay, so here also we will see that f is a feedback, and here we will see x2 to x5 there is also a bypass which will be a gain with g, and here we will see that x5 to x4 is a feedback of h, and x4 to x3 here is a feedback is a e. Okay, and also in a x2 here is a unity feedback of f. Okay, so this is a problem and it will be solved by first of all we will see that forward path. There is a forward path is a two forward path. We know that what is forward path. Forward path means whenever we will start to go and starting point and it will be get from a finishing point. those way we will go from starting to finishing. These path are called a forward path. So here we will go x1 to x5. How? Here when we'll go x1 to x5, here x1 to x2, x2 to x3, x3 to x4, x4 to x5. These are the one way. And we will also go x1 to x2, then x2 to x5. Okay, this is also a way. So we will say that the forward path is a 2. P1 and P2 will be a B C D, and P2 is a G. There are two types of forward path, and there is a 3 loop transmittance. Whichever is a x2 in a F, L1 is a F, L2 is the x4 to x5, and then it will become to x4. So this is also a loop. Therefore we can say that L2 equals to, and here also is a x3 to x4, and it will become in a x3. Therefore it is also a loop. So we can say that L2 equal to CE and L3 equal to DH. Okay, so we can say there is a 2 forward path and 3 loops. Okay, path factor. Okay, what is path factor? Path factor means whenever there is a 2 forward paths, therefore the path factor also be 2. Okay, so del 1 is a for del 1 all loops are connected with a path forward path P1. Okay, like that. These are for x1 to x5 is the forward path A, B, C, D, and there is a 3 loops. These DH, CE, and F. All these loops are touching with it forward path. Therefore, we can say that del 1 equals to 1. For this path, the P2, which will be a AG, we can see that for this loop F is touched and DH touched in a point of x5. So we can say that CE, these loops cannot be touched for the forward path P2. Okay, so we can write for del 2 equal to 1 minus L2, which will be a CE. So 1 minus CE. So these are path factor. Here is a pair of non-touching loop. There are 2 pair of non-touching loop. We can see that DH and CE are touched each other, but CE cannot be touch F. Also DH cannot be touch F. So we can write there is a 2 non-touching loops with L1 and L2, L1 and L3, FC and FDH. From the Mason's formula, we can say that T equal to P1 del 1 plus P2 del 2 by del. We can write P1 del 1 plus P2 del 2 by del is equal to 1 minus summation of all loop plus summation of non-touching loops. Okay, so 1 minus L1 plus L2 plus L3, all there it is a individual loops plus non-touching loops. There is a 2 FC and FDH, which will be L1 L2 and L1 L3. So L1 L2 plus L1 L3. Okay, and there is not in a triple non-touching loops. So this equation is end at this position. After that, solve it. P1 del 1, it can be write that ABCD into 1 plus AG into 1 minus L2. Also we will follow the factors 1 minus F plus CE, because L1 equal to F, L2 equal to C, and L3 equal to DH. 1 minus these factors plus L1 L2 means FCE plus FDH. Solve it and we will find that ABCD plus AG minus AGL2 by 1 minus F minus C minus DH plus FC plus FDH. This will be find out by the solve this equation. Okay, so this is a small thing to find out the Mason's formula and what is a signal flow graph and how it will be solved by simplify one example. Okay, these are way to find out the transfer function of any signal or systems. Okay, this will be help to find out this. Students, I will request you to solve this equation from your reference books, and also the previous block diagrams also. Okay, and see all the notes. It will be helps for your knowledge. Okay. Yesterday we will discuss block diagram. Today we will discuss the signal flow graph. Tomorrow I will discuss the another topic which will helps you to complete your syllabus. Okay, stay with me and follow the all notes. Thank you so much. Thanks for watching.